Good morning students. Today I am going to demonstrate experiment number 3. As we know, our experiment number 3 is interfacing of LCD with microcontroller C8051 F340. So for LCD interfacing we need 3 subroutines. One is delay, one is write command and the other is data command. So 3 subroutines has been initialized. There are 3 control lines on LCD as we know, RS, RW and enable. So RS is connected to P1.5, RW is connected to P1.6 and enable is connected to P1.7. So we have defined accordingly. P1.5 is RS, LCD underscore RS, P1.6 RW and P1.7 enable. According to the interfacing diagram, we have configured the ports as an output. 3 control lines are connected to port 1 and D0 to D7, that is 8 data lines are connected to port 2. So accordingly P1 and P2 are configured as an output. We need to enable the crossbar to enable the port pins. So initially we have enabled the LCD. We have selected command register by selecting RS is equals to 0 and LCD is in write mode. Now whenever we write some commands to LCD, it needs certain delay. Now first we pass sequence of commands to LCD for initialization. Those sequence of commands are 01, 38, 0C and 80. So when we write 01 on LCD, we are going to turn LCD display on cursor on. By writing 38, we are initializing both the lines of LCD. It is the initialization command for 8-bit mode. By writing 0C, after writing each character, cursor should be incremented. And 80 command is to decide the position for the first character, means where you will display the first character, on first line or on second line. On first line, what is the position, first position or third position or fourth position, likewise. So if I write 80 command, meaning is that we have selected first line, first position. So this sequence of command we have written. When you write certain command, we call the command subroutine and we are writing that command. So after giving sequence of commands, whatever the data you want to display on LCD, you can write. So the first character written is W. So we are writing data W by calling the data subroutine data underscore LCD. So first we will write W, then we will write P and then we will write U. So in short, the string I am going to display on LCD is WPU. Every time you need to call the delay after writing data or after writing each character. So we do expect after downloading this program on the hardware, WPU should be displayed on first line, first position. So as I told you, the data delay subroutine has been written, defined, then command subroutine is defined and data subroutine is defined. The difference between command subroutine and data subroutine is only in RS. When RS is 0, it is command. When RS is 1, it is data. So this is the complete program. So we have written the code. We need to build it and get the hex file. Once we get the hex file, we download that hex file on the hardware. So we have interfaced hardware already with PC. We have made it in program mode and we are going to browse for the file. So once we get the file, we need to open it and we need to download it. Once you download that hex file, now you have to go to hardware. So as I told you already, your controller is in program mode and we have successfully downloaded the hex file on the board. Now to see the output, it should be in execution mode. So just press ISP, press reset. Now it is in execute mode. Now we do expect output should be displayed on LCD. Before that, you should know how to connect LCD to this board. So LCD is on ASK board and microcontroller has port 1 and 2. So we have to refer the table given in the manual. So your control lines RS, RW enable and D0 to D7 data lines. All the lines are connected to port 1 and port 2, which is the PL3 connector of microcontroller. So to connect these two, we need to connect PL3 of microcontroller to the PL3 of ASK board. So I will be doing connection accordingly. So I have connected PL3 on microcontroller, and that has to be connected to PL3 of ASK board. So when you connect these two connectors, you need to press reset. As soon as you will press reset, you could able to see the message has been displayed on LCD, that is WPU is displayed on the first line, first position. The important point to note that